Hello, I'm Bas Westerbaan. I'm a research engineer at Cloudflare based in the Netherlands, and today I want to explain postquantum cryptography. So postquantum cryptography is about keeping encryption when the quantum computers have arrived. Quantum computers, although they exist today, are very small and no threat to cryptography, but we expect that in the coming 15, 25 years, they will be big and stable enough to break almost all cryptography we use today. Luckily, postquantum cryptography has been designed to be secure against those attacks, and that's why we are moving to it today. Traditional computers work on bits, on 0 and 1s. It works on making decisions, right? If this bit is 1, this other bit 1, then do this. Quantum computers work on qubits. They're actually closer to how nature works itself, because in nature there is no bits, there's no on and off. Everything in nature is quantum, it's superposition, entanglement. Now, the fun thing is that it turns out that you can use this uncertainty, this superposition, to do some computations faster. It's important to realize that it's not all computations, it's only very specific computations. So in that way you could think about a quantum computer like a graphics card. You use it for something very specific, a graphics card for video games, video editing. And a quantum computer we will use for very specific problems. Breaking cryptography, which is a bit annoying, but there are other applications like simulating nature. So in that sense, it's something to look forward to. What is important to understand about the migration to post-quantum cryptography is that there's in reality two migrations. There's two pieces of cryptography that we use today that are under threat and that we need to replace. The first bit is encryption, and the second bit is authentication. It's signatures, certificates. The encryption, or technically the key agreement, is the most urgent one, because today people can record encrypted traffic, and later, in 15, 25 years, once the quantum computer has arrived, can break the traffic retroactively. At least if you don't use post-quantum cryptography. So that's why we are moving to post-quantum cryptography for encryption today. To prevent store now, decrypt later. What will happen if tomorrow a big quantum computer arrives and we're not using post-quantum cryptography? TLS will be broken. Everyone will be able to read along with everything that's sent on the wire. It's not just TLS, but also digital signatures. This means that software updates, anyone can install rogue software on your computer. With TLS, everyone can read along, but they can't just read along. They can also be in the middle and manipulate things. Everyone will be able to do a man in the middle. Basically, we'll be revert to the internet as it was before, without any encryption or security. You couldn't do online banking anymore, because anyone can read along with your authentication. We wouldn't be paying with cards anymore in shops, because that would be insecure. Anyone could pay in name of you, they could copy the card details. At Cloudflare, we care deeply about a secure and private internet. Which is why 10 years ago, we introduced, as one of the first providers, free SSL certificates for everyone. We want to keep the internet private and encrypted, and that is why we're already looking into post-quantum cryptography. Today, we have deployed post-quantum encryption to secure our users against the threat of store now, decrypt later. We're offering post-quantum cryptography for free. The encryption today, but also everything we'll do in the future. Why? Because we believe that a secure and private internet is a right for everyone. We're not just deploying post-quantum cryptography, we're deploying post-quantum cryptography together with traditional cryptography, so-called hybrid. In fact, what we deployed is Kyber and X25519. X25519 is the most commonly used classical key agreement. It's well tested, it's elliptic curves, but unfortunately it's broken by quantum computers. Kyber is the winner of the NIST competition, and it's post-quantum encryption that we have deployed. We combine Kyber and X25519 so that even if Kyber turns out to be weak, then we can still rely on the non-post-quantum security of X25519. A hybrid is useful if one of the schemes is mathematically broken, but we don't worry that much about a mathematical break. What we are also worried about is implementation mistakes. This cryptography is new, we don't have a ton of experience with it. Well, not as much as we have with classical cryptography. And even if there's a mistake in the implementation of the cryptography, we can still rely on the other. So how do you know whether your website is using post-quantum cryptography? I'm going to www.cloudflare.com. There it's loaded. Now let's go into developer tools. And let's view developer tools. Now we go to the security tab. We are already on it here, but it might be hidden here in the 2 chevrons. On this tab, we see the details about the cryptography that's used. And here, with connection, it says it's a secure connection. But what we really want to know is the key agreement that's used. And that's written here, X25519, Carber 768, draft 00. That's a preliminary hybrid post-quantum key agreement. So we're secure against store now, decrypt later. If you want to see which software and which of our products already supports post-quantum cryptography, check out our website. We'll continue to work to make Cloudflare and the internet at large post-quantum secure. We're pretty far with encryption, and authentication is ahead. Thanks so much for watching, and see you next time.